Alright guys, so this video is going to be over Hess's Law. Hess's Law is a process that we use to find the enthalpy of a reaction based on other reactions of known enthalpies. Alright, so the foundation of Hess's Law is that enthalpy is a state function. And remember, a state function is a function in which the pathway doesn't matter. So if I draw a bunch of squiggly lines, I started right here and I ended right here, it has a much longer pathway than if I just drew a line from there to there, right? So both lines have the same starting point and ending point. The way they got there doesn't matter. So that's a state function. And so if we look at this process for this reaction, carbon plus oxygen going to CO2, the enthalpy for that is negative 393.5. And so if it starts up here on the left side of the screen, where carbon and oxygen go down to CO2, the total process is negative 393.5 kilojoules per mole of carbon dioxide formed. Now, if instead we take both of these reactions and we add them together, so we have C plus O2, and going to carbon monoxide, that is negative 110.5. And then if we take CO to CO2 by adding oxygen to it, it gives off 283 kilojoules per mole. So if we add those together, negative 110 plus 283, or negative 283, we end up with negative 393.5. So it didn't matter how we got there. We can either add these two reactions together or just go straight there. We get the same value because the starting point is C plus O2 and the ending point is the exact same. So it didn't matter how we got there. So Hess's law is based on enthalpy's ability to do that. Okay, so the way that this works, this is the reaction that we don't know the enthalpy to, so we don't know this. And here are three reactions that are given to us along with their enthalpy values, and we can manipulate these reactions in any way that we want in order to get this reaction here. So we can flip them, and if we flip a reaction, that means that the delta H sign has to change. So a positive becomes a negative and a negative becomes a positive. Or we can multiply by a factor. So multiply by 2 or 3 or whatever. But if we do that, we have to do the same thing to delta H. All right, so let's try a couple of problems and hopefully you'll understand it by the time we're done. Okay, so what I usually do is I start with the very first reactant, and this is C2H4. So I know that I have to have one C2H4 on the reactant side. So I look in the reactions given to me and I found C2H4 right here. So it's on the right side and I have one of them, so that's good. So this delta H is going to stay just like that. And I'm going to rewrite my reaction over here so you can see what I'm doing. And be mindful of the phases because if they're different, it'll affect the reaction. And then I'm going to go to hydrogen. Now, one thing I have to watch out for hydrogen is that there's only one of them in the reactions. If there's more than one, I skip that. So, but there's only one hydrogen, and he's right here. So hydrogen has to be on the reactant side, and there is only one of them. So I have one hydrogen here, and it's on the reactant side, so it's on the right side. So I'm just going to rewrite that reaction over here. And I'm going to try to line up my arrows so that you can see what happens when we're done. All right, and so this can stay and this can stay because they didn't change. All right, and then C2H6 is on the product side, and there's one in this reaction that we want. So that means this C2H6 has to go on the other side of the reaction. It has to become a product instead of a reactant. Now we only have one of them, so that's okay, but it still has to be flipped. So I'm going to flip the whole reaction. So instead of having these products on this side, they're going to become reactants. So I'm going to have 3 H2O liquids and 2 carbon dioxides. gives me 7/2 oxygen plus C2H6. And they're all gases, except for the water. When I look at these, I'm going to make sure that everything cancels out and everything adds up to give me the reaction that I want. So if they're on opposing sides, they cancel, and they cancel numerically, okay? And if they're on the same side, they add. So when I look at this, I see that I have 3 O2s here. Now I don't want oxygen in my reaction, so that oxygen has to cancel out. And I have 1/2 oxygen on this side. So that means I have 3.5 oxygen on the reactant side of the reaction. And I have 7/2, which is also 3.5, right? So that means that these 3.5 oxygen that are on the product side, because here's the arrow, are going to cancel out with these 3.5 that's over here. Okay, and then I have 2 CO2 gases. Those are going to cancel out with these 2 right here. And then I have 2 liquid waters, and those, I have 3. So there's 2 here, and then there's 1 here. So that's 3, cancels out with those 3. So what is left is C2H4 plus H2, because they're both on the reactant side, gives me C2H6. So that's the reaction that I want. It's the same thing. So then all I have to do is add these together. Now when I flipped this reaction, right, when you flip it, the sign has to change. So this negative turns into a positive. So now we can add them all together. And what I end up getting is negative 137 kilojoules. So this would be the enthalpy for this reaction, because when these all add together, remember, it doesn't matter how many steps you take, it just matters that your beginning and end is the same, which it is, then that's the enthalpy for that reaction. So here's the reaction that we want, and we're looking for the enthalpy value, and then these reactions below are given to us. So I'm going to start with NH3, and I want 4 on the reactant side. So the only place that I see NH3 is right here, and it's on the product side. And not only that, but there's only 2, and I want 4. So that means that this reaction has to flip, and it also has to be multiplied by a factor of 2. So I'm going to end up with 4 NH3 if I flip it and multiply by 2, and that's going to go to 6 H2 and 2 N2s. And so I'm going to change the sign to positive, and it's also going to be multiplied by 2 because I had to multiply the whole reaction by 2. Okay, and then I get to oxygen. Well, oxygen is here and here, so I'm going to skip that and come back to it later. So I'm going to go to NO, and NO is on the product side, and there are 4 of them. So I'm going to look in my reactions given to me, and I see NO in this first reaction. So I need 4 of them, but there are only 2 here. Now it's on the right side of the equation, but I still have to multiply by a factor of 2. So if I multiply by a factor of 2 here, I have to multiply everything by a factor of 2, not just NO. I'm going to say I need 2 N2s, because it's just going to multiply, we're not flipping anything, plus 2 O2s goes to 4 NOs. Okay, and this is a gas, and this is a gas, and this is a gas. All right, so this gets multiplied by 2 as well. We don't have to change the sign though, because we didn't have to flip the reaction. And then I get to water. So I need 6 waters on the product side. So water is down here, and we need 6 of them. It's on the right side of the reaction, it's on the product side, but there's only 2 of them. So that means I have to multiply this by a factor of 3. So then I also have to multiply this by a factor of 3. So if I multiply 2 times 3 here, I get 6. And then I multiply that by a factor of 3, so I get 3 O2s. And I always try to line up my arrows, because otherwise it gets really confusing when you're trying to cancel out. Okay, so I told you I was going to go back to oxygen. So what I really do is I wait until I have everything flipped or turned, and then I check to see if my oxygen lines up. So I have 3 oxygens here and 2 oxygens here, and they're both on the reactant side, so that would give me the 5 that I need, so my oxygen is good. All right, now what I'm going to do is add all these up and make sure that I get the reaction that I want. The first thing I see is my N2 right here and my N2 right here. There's two of them. One is on the reactant side, one is on the product side. They cancel out. And then I see hydrogen on the product side and hydrogen. There's 6 of them, so they cancel out. And then that should lead me my reaction. So I have 4NH3, 2 O2 and 3 O2, which gives me 5 O2s, 4 NO, plus 6 waters. And so this reaction is this one. And then if I multiply by 2, multiply by 2, multiply by 3, I end up getting negative 906.3 kilojoules and add them all together. So this is the enthalpy for that reaction. And that's it. Okay, so summary, you manipulate the reactions with given enthalpies, the ones that are given, to make the reactions add together to give you the reaction of the wanted enthalpy. If you flip a reaction, change the sign. If you multiply by a factor, you have to multiply enthalpy by the same factor. And so when you add the reactions together, if the compounds are on the same side, they should be added together. If the compounds are on opposite sides, they should cancel one another. That's basically Hess's law.